In this video, I'll give you some tips for solving the ALEKS problem called Understanding Consequences of Important Physical Properties of Liquids. Before we get into this, I want to let you know this is actually a pretty dirty problem. ALEKS has got a lot of weird trick questions in this problem. I don't love it. I am hopefully going to be able to walk you through the variations of the problem that you've been handed, but I know I haven't seen every version of this problem. There's a lot of them. And like I said, a lot of them are really dirty. So ALEKS is going to be giving you information comparing two different liquids, liquid A and liquid B. It's going to be comparing the liquids in terms of two physical properties. So for mine, it's telling me about surface tension and viscosity. There is also a third physical property that could pop up in this problem, and that's vapor pressure. Although you're only going to be given information about two of these three physical properties. So then you've got two different scenarios or two different experiments, and it would be really logical for you to assume that each one of these experiments pertains to one of the properties that ALEKS is talking to you about, maybe not necessarily in that order. That would be a logical assumption to make. Unfortunately, that is not always going to be the case. So for example, you might look at this problem or this experiment that's been given to me, and it says that I've got these 410 gram samples of the two liquids, and it's asking me to compare the volumes of the two liquids, volumes of A, volume of B. Well, what does that have to do with surface tension and viscosity? You might be wondering, how can I make this work? You can't. This has nothing to do with surface tension or viscosity. In fact, this is actually a trick question. This is just based entirely on density. The relationship between the mass of an object and the volume of an object. Grams per milliliter, that's our unit of density. And that has nothing to do with surface tension or viscosity. So this is a trick question, and the answer here is that we cannot make that prediction because we haven't been given any information about the relative densities of these two objects. And like I said, that's one of the reasons why this problem makes me, I feel like I've drawn 3 or 4 frowny faces now. So look out for trick questions like this one that involve a property that has nothing to do with the three properties that are featured in this particular problem. So here's another one. This one says that we have, we're making like films of each one of these liquids, like bubbles, bubble solution. And it's talking about measuring the forces that are needed to make the film, the circle, bigger. So this actually does pertain to one of these properties. It pertains to surface tension. Now let's talk a little bit about surface tension. Surface tension pertains to the forces that exist among the molecules that are up on the surface of a liquid. So if if a liquid has high surface tension, I'm just going to abbreviate that ST. If it has high surface tension, that means that it is going to take a strong amount of force, which is what this problem is asking you about. It's asking us to compare the forces. High force to either stretch or break the liquid, the surface of the liquid. Now, that's all that surface tension pertains to. And remember, ALEKS is going to be really tricky in these problems. So it's going to ask you things like, what about the relative size of these different spheres or things like that? It has nothing to do with surface tension. So size, no, has nothing to do with surface tension. And there were quite a few problems where I saw ALEKS saying it's got like 5 milliliters of a liquid A, and 5 milliliters of liquid B, and they're turned into little spherical droplets. What are the relative sizes of those droplets? No, don't be tempted to answer that question using the information about surface tension, because the size of the droplets has nothing to do with surface tension. And just as a side note, if you get that question, if the objects have, I don't know why I keep saying objects. If the liquids have the same volume, if you have the same volume, for example, it tells you 5 milliliters. That means it is going to have literally the same volume, which means that it is going to have the same diameter. It's going to have the same radius. It's going to have the same whatever type of sphere-related measurement ALEKS might be asking you about. So for this one, it says, I'm being asked to compare the relative forces. Liquid A has a lower surface tension. That means my liquid B has the high surface tension. Liquid B is going to be the one that has requires strong forces to break. So the force of A is less than the force of B. That took me a minute to process. Let's talk a little bit about these other two properties, even though they didn't pop up in my particular problem. Viscosity is a liquid's resistance to flow. So if a liquid has high viscosity, I'm just going to say high visc. That means that it takes a long time to flow. And I saw problems where it was talking about pouring the liquid through a funnel, pouring the liquids through funnels and comparing the amount of time it takes for them to pour. And then this last one, which was also not featured in my problem, vapor pressure. This has to do with the liquid evaporating or boiling. If an object has a high vapor pressure, I'm just going to say VP. That means that it is quick or easy to evaporate. And also it has a low boiling point. I'm going to abbreviate that BP. So if a substance, a liquid has a high vapor pressure, that means it's very easy for it to evaporate. And also it means that it has a low boiling point. Now, ALEKS is pretty dirty with some of these vapor pressure related problems. So for example, there's a couple variations of this problem where it's telling you that you've got the two liquids in a beaker. So you've got like liquid A in one beaker and you've got liquid B in the other, and it gives you information about their vapor pressures. And in one version of the problem, it's saying that it's starting to, like, it puts each of these beakers in some kind of vacuum. So the pressure starts decreasing in the headspace above the liquids. And if you're looking at a version of the problem like that, so if you are in a vacuum or if you are creating a vacuum, the substance that has the higher vapor pressure is going to be quick to, or first, I think is how it's phrased, to boil or evaporate. Now, another version of this problem, ALEKS, is the same kind of thing. It's got the liquids in the beakers, but in this situation, instead of creating a vacuum, it's pumping a different gas in, and so it's increasing the pressure. And in that case, again, that's a trick one. If you are increasing the pressure of these liquids, no boiling is going on at all. Instead of boiling, eventually, if you keep going with that pressure, these things are going to be turned into solids. But if you're increasing the pressure, no boiling. So again, like I said, this is actually, it's a really tricky problem. It's a really unpleasant problem. I hope that you're able to get through it relatively quickly. Good luck. Be nice to yourself while you're working on this one.